Okay, this next section is about the outcomes of a hypothesis test. So we just covered kind of how to begin a hypothesis test, um, but I actually want to give some foreshadowing of where we're going to end up and how that relates to how we began uh, the hypothesis test. So under outcomes of a hypothesis test, there are four possible outcomes. Which of the four possible outcomes, which form the conclusion of a hypothesis test, is determined by how one starts and ends the hypothesis test. The four possible outcomes are inside the hypothesis test conclusion table. So here's kind of like um, an example of a conclusion table with the four outcomes. So what you'll notice about this conclusion table is we've got the null was the original claim or the alternate hypothesis was the original claim. So these two things are what you get at the very beginning of doing a hypothesis test. And this is what we just covered in the previous section. And you remember how I said how important it was that you label which one is the original claim? Because if you incorrectly mark down that the null hypothesis was the original claim, then you're going to think these two outcomes are going to be your answer. But if you are wrong and you mistakenly labeled the null hypothesis as the original claim, then you're totally going to miss what the true answer was. It was either of those two outcomes. Okay, so getting the original claim, whether it was the null or the alternate hypothesis at the very beginning, is really important. Now later, we're going to come to determine whether we're going to reject the null hypothesis or we're going to fail to reject the null hypothesis. Now, how does rejecting or failing to reject and the null and the alternate being the original claim, how does that get you any one of these outcomes in here? Well, kind of simple. So let's say you're working on a hypothesis test and the alternate hypothesis was the original claim. And then by the time you were done with the hypothesis test, you come to the conclusion that you're going to fail to reject the null. Then what you do is you just come down from the alternate being the original claim, and you come over from failing to reject the null, and this is your outcome for your hypothesis test. Okay. So technically, if you were going to guess, you have a 25% chance of getting the correct answer. So it's best not to leave it up to a guess. Okay. Let's see here. If you had another example, and let's say the null hypothesis was your original claim, and you failed to reject the null hypothesis at the end, then your answer is going to be this outcome right here, outcome 3, which is the intersection of this column and that row. All right. Now, this conclusion table where these outcomes, outcome 1, 2, 3, and 4, there's going to be a sentence written in there that you're going to copy, but we'll get to that when we're ready. All right, so I've also pointed out that the alternate hypothesis also is responsible for telling you whether you're dealing with a left-tailed, two-tailed, or right-tailed distribution. And the critical value not only splits the confidence level from the significance level, but it also separates the fail to reject the null region and the reject the null region. Okay, that's all bordered by this critical value. Um, and so what you're going to do in order to determine whether you're going to reject the null or fail to reject the null, there's two common methods that are used. One method is to compare your test statistic to the critical value. So the test statistic comes from your sample data. So, um, you'll have like a Z test statistic that you will calculate, and you're going to see whether relative to this critical value, is it on this side or this side of the critical value? If this number was like more negative than your critical value, then you're going to end up rejecting the null. Or if this test statistic that you get based off of your sample data is greater than the critical value, that's going to lead you to fail to reject the null. So that's one way to do it. And I have to teach you two ways because I think this first way is more compatible with how I've been teaching the class, but this next way is a little bit more how the professional world tends to do it more. So I'm showing you both. Okay, the other way to do it is by using what's called a p-value. So the p-value is a probability value that's calculated by the sample data, and that gets compared to the significance level. So notice something here. The critical value is a number on a number line. The test statistic will also be a number on the number line. So you can compare two numbers on a number line. Okay, you can compare two numbers on a number line and see which is greater than the other. Okay, so you can compare that. A p-value, by contrast, a p-value is an area, and a significance level is an area. So what you're going to be doing is you're going to be comparing the sizes of areas. All right, so based on either comparing a test statistic with a critical value or a p-value against a significance level, that's going to help you determine whether you're going to reject the null or you're going to fail to reject the null in the very end. And whether you reject or fail to reject will tell you which of these rows you're supposed to go across and do it in conjunction with whether the null was the original claim or the alternate was the original claim in order to come to an outcome, a conclusion to your hypothesis test. Okay. So I think that's it for this. Let me know if you have any questions.